Hello, algebra students. Today's lesson is on 2.4, solving multi-step inequalities. Our learning target is I can use multi-step inequalities to solve real-life problems. Yes, that means we'll have some problem solving at the end of our examples. All right, no vocab today. Let's just jump right into example 1. So, solve and graph each inequality. Multi-step inequalities, we're going to treat the same way we would an equation, but with all of the new knowledge we have about inequalities from earlier this chapter. So we're still going to do gemdas backwards. We're still going to use inverse operations. So in part A, I have 2v minus 4 is greater than or equal to 8. I know I need to undo the subtraction first. I know I do that by adding 4 to both sides. 4's on the left cancel out. I have 2v is greater than or equal to 8 plus 4, which is 12. Now to get v by itself, I have to divide by 2. 2's on the left cancel out, and I'm left with v is greater than or equal to 12 divided by 2, which is 6. And we're going to get some practice graphing these. So draw a number line. 4, 5, 6, 7. I'll use a different color to graph this. V is greater than or equal to 6. I know my circle is at 6. It's or equal to, so that's shaded in. Can include 6, and it's greater than, so the arrow points to the greater numbers. All right, part B, I have 2y plus 3 divided by negative 2 is less than 5. That fraction bar is a grouping symbol, so I can't solve 2y plus 3 yet. I have to get rid of the negative 2 first. Now, I know when I divide by negative 2, to undo that, I have to multiply by negative 2. And I know when I multiply by a negative number, I have to flip the sign. So we're going to multiply both sides by negative 2 and be left with 2y plus 3, flip the sign, and then 5 times negative 2 is negative 10. All right, now we solve for y. So we subtract 3 from both sides, cancels out on the left. I'm left with 2y is greater than negative 10 minus 3 is negative 13. And last step, we divide by 2. We're left with y is greater than negative 13 halves. You could say negative 6.5, negative 6 1/2. They're all the same thing. So I'll actually write, because this will be easier to graph, y is greater than negative 6.5. So then when we do our number line to graph, I have negative 7 and negative 6, and negative 6.5 is right in the middle. So circle on negative 6.5, it is not equal to, so I do not shade it in, and y is greater than, so the arrow points to the greater numbers. All right, reminder, if the video is moving too fast, please pause it, rewind. You can rewatch this as many times as you want. Pause it to give you a chance to write stuff down and just process the steps. All right, so example 2, we're still solving and graphing inequalities. We have 6x minus 5 is less than 2x plus 11. So when there's a variable on both sides, we're going to do the same thing we do when we solve equations. We're going to get all the variables on one side, and unless you're multiplying or dividing by a negative, you don't have to worry about flipping the sign. So in part A, the first thing we're going to do is subtract 2x from both sides so that I can combine all my x terms. I can combine like terms. And I'm not multiplying or dividing by a negative here, so the sign stays the same. So 6x minus 2x is 4x. So I have 4x minus 5 is less than, 2x's cancel out, so it's less than 11. Now I need to get all my constant terms to one side, so I'm going to add 5 to both sides. And I have 4x is less than 16. Now I divide by 4. 4 is positive, so I do not flip the sign. X is less than 4 is my answer. And we're going to graph this. I have 1, 2, 3, 4, 5. Circle goes at 4. It is not equal to, so I do not shade it in. It's less than, so it points to the lesser numbers. All right, part B. I have 3 times 2a minus 1 is greater than or equal to 10a minus 11. I see a number outside of parentheses. Instinct says we distribute that first. So 3 times 2a is 6a. 3 times negative 1 is negative 3. So I have 6a minus 3 on the left. It's greater than or equal to 10a minus 11. Now we want to combine all of our variable terms. So I'm going to subtract 6a from both sides. Cancels out on the left. I now have negative 3 is greater than or equal to 10a minus 6a is 4a minus 11. All right, now I want all my constant terms on one side, so I'm going to add 11 to both sides. Negative 3 plus 11 is 8. So now I have 8 is greater than or equal to 4a. 11's cancel out. And now to get a by itself, I want to divide by 4. 8 divided by 4 is 2. So I have 2 is greater than or equal to a. Yes, these are easier to read when the variable's first, so I'm going to rewrite that as a is less than or equal to 2. And we're going to graph it. So 0, 1, 2, 3, 4. And we put our circle on 2. It is or equal to, so I am going to shade it in. It can be 2. And a is less than, so it's going to point to the lesser numbers. All right, these are special inequalities. When we put special in front of equation or inequality, that normally means there's either many or no solutions. So remember back in chapter 1 where we had equations that if they reach a true statement, it's many solutions, and if it reaches an untrue statement, it's no solution. And I went ahead and added this text to the top for you so that you can remember true statement, infinitely many solutions, not true statement, no solution. All right, so let's solve. Part A, we have 8b minus 3 is greater than 4 times 2b plus 3. I see a number outside of parentheses. Instinct says to distribute. So the left side stays the same. 8b minus 3 is greater than 4 times 2b is 8b. 4 times 3 is 12, so 8b plus 12. And now I can subtract 8b from both sides. It cancels out on both sides, and now I have negative 3 is greater than 12. And is negative 3 greater than 12? No, it's not. So this is no solution because that is not true. All right, part B, I have 2 times 5w minus 1 is less than 7 plus 10w. I see a number outside parentheses. Instinct says to distribute. So 2 times 5w is 10w. 2 times negative 1 is negative 2. Less than or equal to 7 plus 10w. Now I'm going to subtract 10w from both sides. It's going to cancel out on both sides, and I have negative 2 is less than or equal to 7. And negative 2 is less than 7. I have reached a true statement. So this is going to be infinitely many solutions. No matter what I plug in for w, that statement is always going to be true. All right, last example for the day, we have some problem solving. Example 4, you need a mean score of at least 90 points to advance to the next round of the touchscreen trivia game. What scores in the 5th game will allow you to advance? All right, so it looks like you scored 95 in the first game, 91 in the second game, 77 in the third game, and 89 in the fourth game. We need a mean score of 90. That means all 5 games added together divided by 5 equals 90. So let's start setting this up. We have 95 plus 91 plus 77 plus 89 plus whatever we score in game 5, which I'm going to say is x for now, divided by 5 has to be at least 90 points. So this is greater than or equal to 90 points. All right, so we want to know what scores in the 5th game will allow you to advance. So we're going to start solving for x now. That fraction bar acts as a grouping symbol, so I have to get rid of the 5 first. So I'm going to multiply both sides by 5. In the same step, I'm going to simplify 95 plus 91 plus 77 plus 89, which is 352. So I have 352 plus x, and now I multiplied both sides by 5, so now I have greater than or equal to 90 times 5, which is 450. All right, now I need to get rid of that 352, so subtract that from both sides, and I'm left with x is greater than or equal to 98. So you need to score at least 98 points in that last game to advance to the next round. All right, let's wrap up with some summary questions. How do you solve a multi-step inequality? Well, we're doing GEMDAs backwards, we're using inverse operations, and we're remembering that if we divide or multiply by a negative, we have to flip the sign. When will an inequality have infinitely many solutions? That's when it reaches a true statement, so infinitely many is true. And when will an inequality have no solution? No solution is when it reaches a not true statement, when it's a false statement. So why is it important to check your work and solutions when there are negative numbers in the inequality? Just like we talked about in lesson 2.3, it's important to check because you can make minor mistakes if you forget to flip the sign, which can then lead you to a completely inaccurate answer.